That would be
1 over square x, or negative. Wait. Yeah, 1 over squared x, right? 2 squared x. Right. And dx.
I multiply the denominator by 2, and I multiply the numerator by 2. And I already took it out. So I have the 2 dx, x and dx right here. So this is my du. What will this become? Everything has to be accounted for, no leftovers.
Square u.
Yes. So this is the square of u. Or u to 1/2 to get it ready. Very good. Everything is accounted for. I write the integral symbol. Now I have to be very careful. When x is 1, how much is u?
3.
Excellent. When x is 4, how much is u?
4.
Yeah. So now I have u to 1/2 du. Excellent. So this is 2, u to 3/2 over 3/2 from 3 to 4. I flip 4/3, leave the 4/3 outside, waiting patiently. The square root of 4 is 2. 2 to the 3rd is 8. Minus, don't forget minus. There is nothing I can do here with the square root of 3. I can't. So this is 3, the square root of 3.
And then we would just leave that as is. We wouldn't round.
That's enough. No, leave it alone.
Okay.
Feel free to choose. I accomplished my task for tonight. We have 20 minutes to work on more problems. You choose.
Maybe we
Oh,
try.
hold on.
You
Oh,
go.
what were you saying?
I was trying to say 68.
Oh, that's the one I was thinking too. I think I might have saw a different one, but 68.
The integral from 0 to pi over 2 from cosine x sine of sine x dx. Very good. What bothers you here?
The sine x in that sine.
Inside x, exactly. This is what bothers me too. So I will say let u sine x. But I have to find du.
So cosine.
No?
Cosine x dx.
Excellent. Great job. So then cosine dx is right here. Dx is right here. So these two will be my du. What about this? What do I change this into? No leftovers.
Sine u.
Yes. Sine u du. Excellent. Careful now. When x is 0, u is?
Also 0.
Excellent. When x is pi over 2, u is?
1.
Exactly. Which function I differentiate to get sine u?
Negative cosine.
Excellent. From 0 to 1. Leave the constant outside. Cosine u, I plug in 1. This is cosine 1 radian. It has to stay as is. Cosine of 1 radian. That's it. Minus. When I plug in 0, what do I get when I plug in 0?
You get 1.
1. You can distribute if you'd like and write 1 minus cosine 1. Cosine of 1 radian. It has to stay as is. Great job.
What about
Se-
72?
Which one?
72.
That's exactly what I was going to write or say. The integral from negative pi over 3 to pi over 3 from x to the fourth sine x dx. Okay.
Wasn't that one of the things we talked about? Because it's got the
Yes,
positive 5
exactly.
3 and then
Yes.
negative 5.
One thing I wanted to mention, since we started the definite integrals here, I did not mention, and I should have mentioned, function must be continuous on the interval 1, 2. It is. The function is not continuous only at 0, and 0 is not here. Because if the function is not continuous on 1, 2, everything is gibberish. Makes no sense. We cannot apply the fundamental theorem of calculus. This function is continuous anywhere to the right of 0, strictly greater than 0. Yes, it's okay. Cosine and sine are defined everywhere. There is no problem. Here, x to the fourth sine defined everywhere. There is no problem. And Amanda already gave us our hint. Every time the interval is symmetric,
We just double it, right?
no,
We go from 0 to pi over 3 and double that.
symmetric is number 1, and 2, odd or even. Odd or even. That makes a huge difference.
Yeah.
Only in the case of even, I write 2. In the case of odd, I write 0 from the beginning. So this is 2, the
But
integral.
this one's even.
This one is odd. Sine is always an odd function.
Oh.
So odd times even is always odd. So the answer is 0. But I have to write why it is 0. I have to write symmetric interval and odd function. That's why the answer is 0. So both conditions have to be fulfilled and written in there. So now here's a question for you. The integral from -3 to 4 from 1 over x dx. It's just a quick question for you. What will you say about this one?
Not possible.
Exactly. Absolutely.
Because you can't have that.
1 over x not continuous on -3, 4 because it's undefined at 0. Hence, fundamental theorem of calculus not applicable. Done. Very good. Okay. Let's choose.
$73.
73. In 73, we have the integral from 1 to 2x, the square of x minus 1 dx. Good. What is the problem here?
The square root with the x minus 1.
Not the square root.
The x minus 1.
Yes, very good. Oh, how much is du?
X minus 1. Oh, sorry. 1 dx.
Exactly. So we have this accounted for. We have this accounted for. What is it?
Square root of u.
Yes, or u to 1/2 to get it ready. Oh, I have this left over. I can't have any leftovers. No worries. How much is x?
u plus 1.
Exactly. No leftovers. So then I have the integral from u plus 1 times u to 1/2 times du. But that's not good enough. What am I missing? What am I missing?
You don't have the numbers.
The limits of integration. When x is 1, how much
0.
is u? When x is 2, how much is u?
1.
Yes. Please remember, do not copy the limits of integration. That would be terrible. And of course, in this case, I have to distribute. I have no choice. The integral from 0 to 1, u to 3/2 plus u to 1/2 du. And please do not go back. There is no need to. The answer is a number. U to 5/2 over 5/2 plus U to 3/2 over 3/2. And that's from 0 to 1. Thank goodness it's from 0 to 1. Because this means 2/5 plus 2/3. Because I only plug in 1. When I plug in 0, everything is 0. So the least common denominator is 15. So 3 times 2 is 6. So there is a 3 here and a 5 here and a 10. So this is 16 over 15. So again, 2 key elements here. We do not go back. The answer is a number. It will be the same number no matter which variable you use. Number 2, we can never copy the limits of integration. Not possible. Okay, ready. $75. The integral from e to the 4th dx over x, the square root of natural log x. Okay, what do you think?
Is it the square, or not the square root, sorry. Is it the natural log x under the radical?
That's it. What about du?
Would be 1 over x times dx.
Good. So let's see what we have. That's my du. And this is the square root of u, or u to 1/2, and I will bring it up. Do not copy the limits of integration. So I have u to negative 1/2 du. When x is e, how much is u? When x is e, how much is u?
One.
Yes. When x is e to the 4th, how much is u?
4.
Exactly. So this is u to negative 1/2 plus 1, which is u to 1/2 over 1/2 from 1 to 4. Or 2 the square root of u from 1 to 4. Leave the 2 outside, plug in 4, get 2. Minus when we plug in 1. 2 minus 1 is 1, so the answer is 2.
Hello. No, 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 no.
So please remember the limits of integration cannot be the same. And there is no reason to go back to the original variable. The answer is a number, and it will be the same number no matter what. Okay. Did we get the idea?
Mhm.
Okay, let's choose one more and then we can stop. What about, yeah, go
67.
ahead. Which one?
67.
67. Well, it's the same thing. The function is odd.
Oh.
The function is
I
odd.
assumed it's
This
66.
is the interval is symmetric and the function is odd. Odd and odd.
It's odd because the tangent x.
Because of x cubed and because of tangent x, yes.
What about something like 69 where dx is part of the?
Yeah, that's fine. Let's look at 69. In 69, we have the integral from 0 to 13 from negative dx over the cube root of 1 plus 2x to the second power. Very good. Good pick. Excellent. So what is the problem here with this one?
The 1 plus 2x
Good.
squared.
No. 1 plus 2x. See, that's why this is important. When you look at this quantity, you have to see this.
Oh, right, it's 2/3. Okay.
Good. So can anyone give us the du? Because without the du, we cannot continue.
Would that be 2 times dx?
That's it. So then obviously I need the 2 to multiply the top and multiply the denominator. Okay? So 2 dx is my du. I will put the negative outside with 1/2. So negative 1/2. Do not copy the limits of integration. So I have negative is outside. 2 dx is du. How do I replace this by? This piece.
So 1 plus 2x. So hold on, wouldn't that just be u to the power of 2/3?
Exactly. So u to
Oh.
negative 2/3 du to
Okay.
get it ready because it was in the denominator. Now careful. When x is 0, how much is u?
X is 0.
1.
Yes. When x is 13, 2 times 13 is 26 plus 1 is 27. Very good. Good. Almost there. So then we have a negative 1/2 outside. And then we have u to negative 2/3 plus 1, which is 1/3 over 1/3 from 1 to 27. I have to flip this. I get negative 3/2, leave the constant outside. Plug in 27, the cube root of 27 is 3, minus, when I plug in 1, the cube root of 1 is 1. So this is 2 divided by 2, which is 1, so the answer is negative 3. Let me also show you one time before we adjourn, again, how to calculate this and determine it or check if you would like. Oh, where's my integral? It was the integral from 0 to 13. And that was negative 1 over how do I write this? 1 plus 2.
You use parentheses in the power 2/3.
Yes. 1 plus 2x. I meant to say, I was thinking to put it as negative, to power negative, but that's okay. Because I have two options. I either keep it in the denominator or I put it in the numerator with the negative power. That's what I was trying to say. So when I click enter, if I don't get -3, I have to go back to the drawing board and see what is happening. Okay, the calculator took a while to think about it. Did you see that? It didn't like it very much.